forge bonding process is takes place by applying a heavy, we call it an axial load on the stud. It's and then we rotate that stud for just seconds, and we're applying this load against a tank shell, a tank roof. It can be applied on any metal surface, and during that rotation, at the tip of that stud, there's some friction generated that heats the tip of that stud and the base metal that it's being pressed against. And those metals are softened to a clay-like consistency. It's called plasticizing the metal. And it never reaches the molten temperatures like fusion welding does. And so that's one of the reasons that it produces such little thermal energy. So under this pressure and rotation, while that metal is plasticized, the two metals are fused together. And that bond that's created at the base of that stud is actually stronger than either of the two metals that are being fused together. And this process, friction welding in general, is very capable of joining dissimilar metals, which is more difficult for fusion welding technologies. So we commonly are bonding, our stud is made out of a different material than the base material, and that's a very, very common process. And we can also bond on exotic metals. We've recently qualified zirconium. We're bonding zirconium studs on zirconium base plates. And so the metallurgy is very important in the process and the recipe that it takes to join the two metals. If you've been noticing, in fact, Mike pointed out earlier in the discussion, the repair plate that's behind him, that's at a refinery in the Texas area, in the Houston area. And that happens to be a 2205 duplex scrubber. And that plate, the repair plate, is also 2205 duplex material. And we had to choose the stud such that it matched, or not, it wasn't the same metallurgy, but it was a similar metallurgy that had the capability of performing a very high quality, high strength bond. So our engineers had to work on developing that welding procedure and welding process, and of course qualify it to ASME Section 9. And then we had to educate our technicians on that new welding process specifically for this metallurgy. And that's common for us to have to adapt our process, and our equipment is very capable of adapting the process to the metallurgy involved. So there's many parameters that can be involved, that are involved in adjusting the welding procedure so that we can bond on just about any surface. And it turns out that friction welding is very capable of being used on a very wide variety of materials. It can actually be used on non-metal products, although Forge Tech has all of the work that we've performed today has been on metal, but there's other materials that can be friction welded, but we're not getting into those at this point in time. That may be in our future. But when you apply a large force to a stud to perform the forge bonding process, you've got to be able to attach your equipment to the tank, and the amount of force we need is far greater than a technician could produce just by holding the machine by hand and pressing it against the surface. It takes many, many times more pounds of force to be able to generate a bond with that stud against the material. So we use clamps. There's a variety of different clamps we use to attach the forge bonding machine to the tank or vessel for that matter. We do pressure vessels as well. We've made, in fact, we've done quite a few pressure vessels up to, we did a 99 PSI tower recently. We've actually implemented a process up to 150 PSI for applications is that high. And we've tested it in our shop well over 1,000 PSI. So the capabilities for our technology, we haven't even seen the limits yet. But we use various clamping techniques to apply this force to the stud. And I won't get into too much detail on those, but just in general, if it's a small vessel, such as the one that Mike has behind him, I think that was 5 foot in diameter. We've bonded on smaller diameters and of course, when the diameter gets on smaller diameter vessels, you can actually wrap something around the vessel to hold the machine against it. But when you get onto large vessels, say a 300-foot diameter crude oil storage tank, you're not going to be wrapping a cable or a clamp, a chain around that vessel to hold the machine against it. So we use vacuum to hold our machine against the tank shell. And we have various techniques, and frequently that's part of our design, is designing a vacuum clamp, so to speak. We design the vacuum clamp to adapt to the particular situation to avoid obstacles. You can see in that picture behind Mike, to the left of that plate, there's an obstruction there that could prevent us from attaching our vacuum clamp to the shell of that vessel. And so we have to get creative sometimes and that becomes part of the design process. We have to get creative in designing the vacuum clamp to attach our machine to the shell. And then the machines simply run off of air. There's no electricity, no electronics. You can say that we weld with air with our process, and it's all powered off of a 185 CFM air compressor or larger. Typically that's towed in behind a truck, and it sits on the ground. Typically it can be inside or outside the dike, depending on the permitting and the requirements of our customer, of the equipment owners. And so it's a very straightforward process. Air is very safe to work with. And it's frequently we're operating under cold work permits. Sometimes the customer isn't comfortable with that, so they'll permit us with a low energy hot work. And sometimes after they see our process at work on a few jobs, they'll downgrade us to cold work. So it all depends, and we work with the customer very closely. It all depends on the conditions that we're working in. But yeah, that kind of sums up the way that our forge bonding process works to join a stud to a tank.